How does NASA's supersonic aircraft eliminate sonic booms? The sleek, elongated design of the X-59's fuselage, with the cockpit positioned above the body, helps streamline the aircraft, preventing supersonic booms from occurring behind it. Currently, NASA is collaborating with Lockheed Martin in hopes of revitalizing commercial supersonic flight by minimizing sonic booms. Their X-59 QueSST, Quiet Supersonic Technology, project aims to eliminate the speed limit on land, when supersonic booms are no longer a concern. Other aircraft, like the Northrop F-5E Tiger II, demonstrated in 2003 that the shape of the aircraft can reduce the intensity of supersonic booms. The X-59 is designed to go even further, creating supersonic booms of only about 75 decibels, equivalent to the sound of a washing machine. Many up-and-coming companies in the supersonic aircraft manufacturing industry believe that commercial flights, at speeds faster than the speed of sound, will not only be feasible, but will also be designed, built, and licensed within the next 5 to 10 years. Supersonic flight will revolutionize the aviation industry, helping passengers save time, according to Yahoo. Supersonic booms remain the biggest obstacle to the development of such aircraft, according to David Richwine, Deputy Director of NASA's X-59 project, a test aircraft designed to minimize the noise and vibration of sonic booms. Supersonic booms have been known since Chuck Yeager broke the sound barrier in 1947 aboard the Bell X-1. It is the loud noise caused by shock waves formed when an aircraft exceeds the speed of sound. Initially, it was seen as a sign of progress, heralding the era of supersonic flight. In 1963, President John F. Kennedy introduced the Supersonic Transport (SST) initiative with the goal of creating a supersonic commercial passenger aircraft capable of carrying 300 passengers and flying at speeds over 3,700 kilometers (h). But by the end of the decade, most people viewed supersonic booms as a public nuisance. In 1968, an F-105, flying over the Air Force Academy, shattered 200 windows of a nearby chapel, injuring dozens of people. From 1956 to 1968, the U.S. Air Force had to deal with about 40,000 complaints about supersonic aircraft, paying for damages caused by broken windows and cracked plaster in homes. Concorde, the world's first commercial supersonic aircraft, also could not overcome the problem. Developed by Britain and France, Concorde's transatlantic flights often resulted in broken windows in many U.S. cities and vibrations that frightened local residents. In 1973, the U.S. Congress and officials around the world banned supersonic flights over land. With expensive tickets and high fuel consumption, Concorde made its final flight in the UK in 2003. The idea of the X-59 was first introduced in 2018. NASA allocated $248 million to Lockheed Martin to develop the jet. After computer modeling and wind tunnel testing, the X-59 was officially unveiled at Lockheed's Skunk Works facility in California in January 2024. The sleek, slender aircraft measures 30.4 meters in length and 9 meters in width, resembling a futuristic fighter jet with the cockpit nestled between the fuselage. The vehicle is designed to fly at Mach 1.4, 1,489 kilometers (h). The X-59 reuses many parts from other aircraft, including the landing gear of the F-16, the canopy and ejection seat of the T-38 supersonic trainer aircraft, and part of the engine system used on the U-2 reconnaissance aircraft. Placing the engines at the front of the aircraft allows the lower portion of the fuselage to become smoother, preventing shock waves from forming behind the aircraft, thereby reducing the intensity of supersonic booms. The aircraft has undergone numerous ground tests, and is expected to take off later this year. The X-59 will fly at speeds of 1,728 kilometers (h) at an altitude of approximately 16,764 meters, equivalent to the speed and altitude of commercial supersonic aircraft. According to NASA, the data collected will help lawmakers reconsider regulations banning supersonic flights over land. The cockpit configuration in the middle of the aircraft's length means that pilots will not observe through windows at the front. Instead, they will use high-resolution cameras and a 4K monitor in the cockpit, called the external vision system. When the X-59 takes off, the vehicle will undergo safety tests, followed by a period of sound evaluation, before NASA conducts a series of test flights in cities for residents to provide feedback, helping determine if the technology has reached an acceptable noise level. We hope you found today's episode informative and engaging, and we look forward to bringing you more fascinating stories and insights in future episodes. Be sure to subscribe to stay updated, and and join us for our upcoming episodes. Thank you once again for being part of our community. Until next time, stay curious, stay inspired, and we can't wait to reconnect with you in the next episode.